All right. Hello, everybody. Welcome back to another Rust Gamedev Meetup. This month is February, and I'm really excited about today. We have like 7 presenters today, which I feel like the first Gamedev Meetup we had, it was very unorganized, and I kind of just like anybody who wants to come, can come out. And it went for like 2.5 hours, and I think we're going to achieve another like 2-hour, maybe 2.5 hour day today. And so we have a lot of really cool content that we're going to be getting into. So first off, what is this meetup? And so, I mean, if you've been here before, you know, but I do want to specify this is about the Rust language. We're not talking about the Rust game here, even though we are talking about game development. And so this is an opportunity for people in the Rust game development ecosystem to come and show off what they've been working on over the past month or past few months, to get shout outs. So I'll be keeping an eye on the chat for YouTube and Twitch, seeing if there's anybody who's been doing some cool stuff recently. Also, an opportunity to chat with other people in the Rust ecosystem. And so after the meetup is over, we'll be moving over to Discord, to the audio chats. If you want to ask any questions to people, if you want to talk about people's projects, we used to have it, and actually this is like good to specify, we used to host it specifically on Discord, where we would all be in like a room together, but we're trying StreamYard this time. And so that's why we got like the nice leaves in the background and the audio working first try kind of thing. And so there's a lot of kind of cool stuff that we get with StreamYard, but then there's also some difficulties here and there, and we'll kind of iron them out since this is the first time that we're trying it. So as I mentioned, if you have any shout outs, put them in chat. I love reading stuff that's going on. And also I have this like cool ability to show off comments here on StreamYard. And so I can show what people are saying. If people have cool projects that they're working on, then I'll be sure to toss them up here and there. And yeah, I mean, hopefully this works out pretty well. I really want to see this type of format, like StreamYard's just making different like just other presentations and stuff. So we had the Rust Graphics meetup a while ago. I want to see if we can have maybe different types of meetups as well. And it's really easy to like record and show this stuff off. But anyways, we're here to do show and tell today. We're here to see what cool projects people are working on. So we will be back in just a minute with our first presentation, and we're going to be diving into Hotham by Kane. All right, so we're trying our first transition here. Definitely a lot less transition-y fading in and out, but we have the first topic here. Kane is coming to us all the way from Australia this bright and early morning, and so I've put him right at the beginning just so we can get his 3 a.m. Over with here. but Kane, I'll let you take it away.
Awesome. Thanks so much, mate. Well, g'day, everyone. My name is Kane, and today I am here to talk about Hotham. I will be first talking about the fact that my slides aren't showing up. All right, we can make do. So first of all, who am I? This is my serious developer face, and the rest of the text that I had showing up here isn't going to show up because my mouse actually isn't working. But basically, I'm a developer that's been working mostly with network security for the last 10 years. About 2 years ago, thanks to COVID, I wound up the startup that I was working on and have been getting into game development. I started off building a chess game in Unity and then ported that to VR. And as you do when you start working with Unity for more than 10 minutes, you decide to make a game engine. So what is Hotham? Well, Hotham is a framework for creating incredible VR experiences, emphasis on incredible and emphasis on VR. It's written in Rust, as you might imagine, but I think what makes it really interesting is it's specifically targeted for standalone VR experiences. And in case you aren't familiar with VR, there's really two flavors of VR. There's PC VR, which is you have this headset that essentially shows the frames that are rendered on your PC with compute, CPU, and GPU. And then there's this thing called standalone VR, which is basically an Android phone in a box with really bad glasses. And so while that sounds like a terrible proposition, the advantage of it is you get a lot more immersion by not having to be tethered to a cable. And it's obviously a lot cheaper and a lot more accessible to people that can't afford a multiple $1,000 computer. So the kind of the idea with Hotham is that because we're running on this low powered hardware, it's designed to be as performant as possible. Obviously, this is a goal. We're not there yet. This is eventually where we'd like to get to. So really, I guess the question is, why would you want to build a VR game engine in the first place, just beyond the obvious yak shaving? And as I said before, the reason was sort of uni drove me nuts, and we don't really need to get into the details on why that is, but specifically for VR, the process for building applications using it is a little bit unpleasant. And look, there are some really great alternatives for game engines. We in the Rust ecosystem in particular, we have Bevy. And so one of the questions that comes up a lot of the time is why not just be a Bevy plugin? And there's a whole bunch of reasons for this. And we've actually got some more stuff in detail on our GitHub. But essentially, it sort of boils down to Bevy doesn't yet have some great OpenXR support. I know there's some really, really smart people that have been working on that for a while, and they've made some huge progress. And also Android support on Bevy also just isn't quite there yet. So there's a bit of technical groundwork that was sort of not yet in place when I started looking at this. But it's also because standalone VR is just really, really hard. I mean, to kind of give you a flavor for this, if you look at the requirements that Oculus puts on games that make it into their store, the first one on the left here is that the app must run at specified refresh rates. And what they mean by this is it's always running at the specified refresh rates. Frame drops in VR are totally unacceptable. In a normal game platform, it might cause a player to be irritated, or perhaps they might even notice it. But in VR, if you start dropping frames, people throw up. It just makes the experience extremely unpleasant. So when they say you have to run it, 72 frames a second, they mean it, and they will reject your titles if you don't. The other really interesting thing, the other fun thing, is that they test whether your app can run for 45 minutes without entering thermal throttling power state, which basically means that you need to be quite careful about how much CPU and GPU that you're using. Because, again, you're kind of using this computer that's strapped to your head, and heat is important, especially when you're rendering like these two quite big screens at 72 hertz. I mean, you can run at 60 hertz, but 72 hertz is the default, and anywhere up to 120 hertz is supported. And again, just to give a comparison of the hardware here, if you compare the Quest 2, CPU is there on the left and GPU's on the right. Even though the CPU is probably not too bad, the GPU is extremely underpowered compared to even modest desktop GPU hardware. And again, this is all if we're running it at maximum power. We are not allowed to do this. We can't run at full power all the time. If you do that, the device will get hot and you'll melt people's faces, and faces don't grow back. And you might just think, well, okay, this is just like GPU bound. Why don't you just reduce the vertices and the scenes and everything will run fine? But it's actually a lot more complicated than this. There's a fantastic talk by the team from Superhot who've produced it. It's a very popular game in VR, talking about how they went from PC VR, or 100 watt power, to 4 watts in 12 months. And it's really interesting to note that 12 months is actually longer than it took them to develop the game. So it took them about 6 months to develop it for PC VR and 12 months to port that existing game over to the Quest. It's not an easy value proposition. And in that, they talk about how, some parts of that process are GPU bound, some parts are CPU bound. It is really quite complicated. So with all of this in mind, and having had this background, I was actually on a hike on Mount Hotham. This is a real life picture of it in the summer. It's pretty gorgeous that I took. I just thought, well, why don't we start from scratch? If the existing game engines are really not great for doing this. Why don't we start from scratch with this specific target in mind? And the thing is, usually starting from scratch is always a terrible idea, and it may still prove to be a terrible idea. But the cool thing is, if you're focused, it lets you skip lots of things. So this is not a general purpose game engine. It's not trying to be. It's trying to do one thing and do one thing well, which is to create great experiences for mobile VR. And so because of that, it means you get to skip lots and lots of things that normal game engines have to support, like different input devices, being able to scale to different resolution, 2D graphics and so forth. Even things like isometric cameras, like these things just don't exist in VR. And so you can really get to skip a bunch of them. The other thing is that OpenXR, which is kind of the de facto framework for building VR experiences now, is actually really great. And it really does away with a lot of the annoying problems that you might experience with desktop or other device rendering. So, I got very excited about this. I was about to start building this, and I realized there was just one problem, or the first problem I had, which is I actually didn't even know what a vertex was at this point. At the start of 2021, when I was about to build this engine, sure, I'd built a game. I'd got some things working in Unity, but I had never done any low-level graphics programming whatsoever. So I learned me some Vulkan, as you do. I made a triangle. And then I encountered the second problem, also a big one in the games world, which is I didn't know. I have terrible understanding of maths. I failed high school maths because I played World of Warcraft instead of doing any maths. So don't let your kids play WoW if you want them to do well at maths. So I learned some linear algebra. I learned how to do some vectors, and then I sort of needed a bit of motivation. So I bet my friends $1,500 that I could render a GLTF object in VR at 72 hertz in 30 days of actual cash money dollars, which was a terrifying proposition that I immediately regretted about 2 days after doing it when I realized how hard it was. But luckily, after a lot of frantic work, a lot of coffee drinking, and pulling my hair out, I did it just with about 16 hours to spare, but I got it through. And just as an aside, if you are working on something for a while and you feel like it's not getting anywhere, I highly recommend this. Not for everyone, but if you're like me and you procrastinate all the time and you need a kick in the pants and need some external pressure to get things done, this is just a fantastic way of doing that. So I highly recommend it. So fast forward 8 months, and this is where we do the from Wayne's World, and now we've got Crab Saber, which is a playable, full, functional demo of a game written in Rust. Now I'm going to cross my fingers and hope that the video actually plays here, because I'm not getting any input into Keynote. And oh, we got something. Give me 1 second. All right, so here's the video playing. So on the left-hand side, we've got the input from the headset. On the right-hand side, we've got me looking like an idiot. And game over. So that's pretty cool. I'm reasonably proud of this for having gone from not really having a lot of experience at all with game development to having this running at 72 hertz and reasonably low CPU and GPU, e.g. like it would meet the Oculus Store guidelines. I think that's pretty cool. Now, here's where the caveats start. This is obviously an extremely trivial game, very trivial scene. There is so much more work to do to actually build like games that are anything like what's currently available. For example, if you were to load Sponza into the scene, like you will get a lot of pain. By the way, Sponza is from Croatia, and pain in Croatian is bol. But yeah, with all that in mind, let's dig into some of the technical design. So one of the things about Hotham is it's extremely boring. This is not an accident. This is actually part of the stated design goal. Because I don't sort of have the background, I don't have the expertise to sort of create anything exotic or unique. It really is just trying to be as simple and straightforward and predictable as possible. Really, as far as possible, I've tried not to reinvent the wheel or do anything remotely interesting. I mean, except for, yeah, okay, but the whole game engine thing. But really, it's trying to use just really powerful, amazing off-the-shelf software like OpenXR, Rallus, awesome wrapper around that, Hex, which is just brilliant, GLTF, using Ash, so we've got low-level access to Vulkan, the amazing Rapier and Algebra. We've got audio for spatialized audio and eGUI for all of our stuff. So with that in mind, let's see some code. So as always, when people share code on YouTube, get ready to squint. So there's no app API per se, which might be a little bit unfamiliar to begin with, but you call the engine, you write a loop, you initialize the engine, and you, in a while loop, you update the engine every tick. So each tick kind of looks a little bit like this. This is an example from CrabSaber. You essentially collect the input, which is you sort of gather the state of the external world, external from the perspective of the engine. You update the world. So you update the ECS, which is the source of truth based on the current state of what's going on. And then you run your game logic, which for CrabSaber is implemented just as a finite state machine with tests, and it's just like any other state machine. It takes in the current state and it emits a new state and transitions between them, which is pretty cool. We then process the output, so we do things like render the GUI, we apply haptics or play any our spatialized audio, and then we render. We just take the scene that we've produced by doing all those things and we pass it to the renderer. The renderer is, you could call it awful. I would call it adequate. It really is just like taking some examples from Hotham for PBR and really just making those work in Rust. It's nothing special at all, and lots of work still to be done. But at least I can render that dark helmet. There's no render graph with pretty cool stuff like that. There are no custom shaders. You have to use the one shader and the one render pipeline that we give you. It only imports GLTF assets. It is boring. It is very, very boring. But that's where it is for now. We have grand plans for the future and where we're going to be getting to. So I'm lucky enough that I was able to work on Hotham 100% full-time last year, but unfortunately money is a thing, and so now I'm doing a bit of part-time work. But I can work on Hotham essentially 70% full-time for the foreseeable future, which is pretty cool. So what I want to do is make some games. Now that I've got this engine, part of the reason for building the engine to begin with was wanting to make some games. But the idea is that games should be driving the features here rather than the other way around. I mean, there are a bunch of really obvious features that we need to have, like there are no shadows, we need more detailed scenes, we need more lights, there's no networking, we really want to be running at 120 hertz. I mean, gosh, maybe we'll even have an editor, but there's a lot of work that still needs to be done. If that sounds like it's something that's interesting to you, then yeah, get involved. We've got a really nice little community of some super smart and super friendly people. Very nice, I promise. Jump onto the GitHub. You'll see a link to the Discord there, and you can see what needs to be done. Before I wrap up, obviously, just need to do some thank yous. First is to Ralph. Anyone that's part of this community knows that he's ridiculously smart, equal parts smart and generous. Really, without him, would not have been able to get Hotham off the ground. Will Brickner on GitHub was one of the people that first sort of helped getting anything really running on the Quest headset at all. The amazing Sinelth and Gem 1 Gardner from the Hotham community, who are actually sponsoring the project. Gosh knows why, but God bless their hearts. They're wonderful. My loving and infinitely patient partner, who has put up with me over the last year while I built this and has stayed up till 3 o'clock in the morning to watch my presentation, which is lovely. And thank you, you wonderful human being, for watching this. So yeah, that's the end of the presentation. I'm not sure if we have time for questions, but that's it for me.
Awesome. So I will do about just 1 or 2 minutes of questions, and these are just stuff that I'm thinking on my own here. But first of all, it was super cool seeing the demo. And so what I was sort of wondering is the process behind making the demo where you can implement some mechanics and do a little bit of this stuff. how much of that was like you really just having to work in the confines of like without an engine, just kind of adding your own logic, or rather, how extensible would it be to add or to make more games with the current state of it?
That's a really good question. I don't have a good answer for that. Really, the idea was to create a demo first and let the engine fall out of that, rather than the other way around, to just avoid infinite yak shaving. So that's next week. Really, that's what I intend to find out, is to try and make some games and see what happens. But if anyone else wants to give that a go, I'd love to hear how you go.
Perfect. And I know my brother just got a Valve Index, and so I kind of have been like getting the itch to play around a little bit with some of this stuff. So it would definitely be super cool to yeah, I kind of like play around. And I think Connor mentioning here, that's a super smart way of doing that. So like having a game that the engine falls out of, so even if you're building something from scratch, this is like the dream of people, to be able to like have something that they can use their technology for. And so yeah, this is a super cool way of going about it. All right.
Yeah. I think just one thing to add, I think just a lot of this comes from me being inexperienced in this area, and not being able to make certain assumptions. And so I think that I've just had to kind of guess my way through it.
And definitely also like motivational to hear that like without the necessarily like big math background, you were still able to get your toes wet and really come out with a really amazing product here at the end. And so I'm definitely excited to see where Hotham goes in the future. And I don't think I've seen it in the Gamedev newsletter, so do make sure to post some stuff about it next month. That'd be very cool.
Would love that. Right. Thanks.
Awesome. Thank you so much, Kane. And maybe we'll see you here in a future month. Cheers. All right, so welcome back. I still have Kane on the screen with me here. There we go. So we are back with Dimitri, aka Quark, who's going to be talking to us about Baryon. Now, Quark, we just see the Firefox screen right now. Should it be the presentation?
Yes. Do you see the presentation full screen in Firefox?
No, it's just the Firefox window here.
Interesting. You're supposed to see the screen, right? And I'm switching the tabs to.
So right. So I think we've had this before on. Actually, it might have been with Kane's, where we had to like switch some stuff around a little bit just so it could capture full screen.
Do you want to show the slides, and then I can comment on them?
Yes, I can do that. That is a very easy way to handle it. Let me just get that set up on my end here.
Technical difficulties.
Classic. All right.
Thank you.
Oh, all good. I will leave you to it, and I'll just try to follow along as best I can.
Thank you. Hello, everyone. So I'm Dimitri, and I want to tell you about this little thing I've been toying with. It's a prototyping engine called Baryon. Next. It's inspired by 3RS, which is an engine I developed previously. It was based on GFX pre-low level, so the first and famous GFX. It supported only OpenGL, but the API was so easy that it was straightforward to build games like this. Or there was a very inspiring game called Arboids, the simulation. And I want people to build more of those. But by now, 3RS is like 2 generations behind, because it's not on the new GFX, it's not on WGPU, and just porting it over seems like a big task. So I thought I would rethink this from the ground up. Next. I want it to be easily prototypable, so build games quickly, basically. Of course, based on WGPU. I want it to be scalable if I want to build a strategy, and I don't want any magic in the API. I want it to be readable. So like macros and like a huge number of trades included, that part I'm not a fan of. Next. And the first thing I try to figure out for myself is what's the distinction between different things and who provides what. And material and mesh are typically something that's provided by the user some way or another, and render passes may or may not be provided by the engine. And the way I approach this largely is that both material and the mesh are just data, and render pass is code, basically. Next. And a lot of questions for prototyping that people, if you're building custom pipelines, you may ask this. If you're just toying with cubes around in only enable PBR, then it's probably not something you're concerned with. But if you don't know what you want your game to look like, then you ask yourself, what are my vertex attributes going to be? What is the material that I'm going to use? And how much in all of that should the engine be opinionated about? And so I decided that I will split the engine in two parts. One is going to be non-opinionated at all, and it's not going to know what your material is or your even vertex attributes to some extent. And the other part will know about everything and provide everything. So the core depends on WGPU, uses hex, ECS, and image for images, and it doesn't know what your stuff is, what your data is. It doesn't know, it doesn't have any passes, but it has the infrastructure to build some. And then there is the batteries included crate on top of it, which hooks up to Leon for 2D graphics, GLTF for resources, and WinIt for window initialization, and it uses the core. Next. You noticed hex there, so why ECS? I mentioned it needs to be scalable, and we know a lot of engines are adopting ECS one way or another. The most famous are probably Bevy. Ren 3 also uses something like ECS inside, but it's homegrown, and Dotrix definitely uses ECS. So I wanted to see how they are similar or different to what I want. Next, and this was a task of finding differences, but in fact I found that they're largely doing very similar things. So this would be a little bit educational here. So in Dotrix, you would spawn an entity like this, and this entity structure that you are creating is just a constructor for a bunch of components, basically. I would call it a bag of components or a component bundle. So it's not what the component look like internally in the ECS. However, there are meshes, and when your system renders an entity in Dotrix, it expects a certain mesh, but it doesn't actually check for any of the mesh contents. So meshes are just expected, they're not abstracted away as a part of the ECS. Next. In Ren 3, similar situation, meshes currently contain a fixed set of attributes, and there is an expectation all over the place. But I know Connor is working on this to make it more flexible. I would like to point out that those long explicit types is something I appreciate. So there's different things that people choose to do, and this one is good. And there is an object type which has a single material, as far as I can see in the mesh. So it goes in contrast with my idea of material just being like a bunch of data that is being processed. Next. Finally, Bevy, it spawns a component bundle, the PBR bundle, which similar to Dotrix has just a number of things in it. It's very powerful, and I don't want to what it cannot do. It can probably do a lot of things. But I also know that I asked around, and they're working on the more powerful vertex attribute system right now. So perhaps they're catching up to something I'm going to show here. Next. Yeah, so in my understanding, vertex attributes are just data, just like material can carry textures. When you're writing a shader, you basically don't care that much whether your data comes from vertex attributes, from storage buffers, or from textures. So the difference between like this comes from a mesh and this comes from a material for me is not drastic at all. And I don't want to like draw a line between those. The line should be very, very subtle. And so the core doesn't even know what the material is or a vertex position specifically is. It's fully abstracted of those things. Each entity is just a bag of components. Next. This is how you create one. The first one, you create a mesh prototype. Then you see the builder pattern as in other engines as well. You say something has a position parented to some node, and you spawn an entity. And the important thing here is that an entity knows, like, points to the mesh, but it's abstracted from the actual attributes that the mesh has. So this geometry cuboid at the top, it can be your own thing that has your own attributes, and it would still work the same way below when you construct the entity. And the most fun thing is the one line before the last one is when you say component level.color, because that's your material, but the engine doesn't care. For it, it's just some data on your entity that you are attaching to, just like ECS is supposed to be driven. Next. And when you need to draw it, you have a path that you create, and these are defined in the patterns included part. When you need to change any objects, you just access the scene directly as a container for nodes, and you call draw. Next. So this is probably the most important thing here. The node hierarchy is not a part of the ECS. I don't think it needs to be. It's just too different. And the block at the center here is the entity. And it has each of the color bits there is a component. So the base component is just like I am an entity, which points to some mesh and some node hierarchy. But mesh at this point is fully abstracted. Then each vertex attribute that the mesh has is represented as a component there. You see the position and normal. These are just special components, and they get populated from the prototype which we created in that code earlier. And then material is just a bunch of data, like color and texture. There can be other data there because there's no difference for the render path between a material and something else. It's just something we call a material, basically. So you can write your own sort of rendering pipeline where you check, okay, does it have, it must have a diffuse texture, but it may or may not have a specular texture. And you just work with it like in the ECS way. And similarly, it can check, okay, I need all meshes with position, but maybe not texture coordinates. And again, it's going to work the same way as ECS is supposed to do. It's going to match those meshes, selecting those components that have position, but not necessarily texture coordinates per vertex. Next. This is how rendering path looks like, which you can write. So it's just world query for entity and color, which also have, you see, vertex position. The position type is defined outside of the core. So core does not know what a position is. It's just something this render path defines itself. And then it gets all the data from the mesh and from the spatial graph and just draws it. So it's fairly straightforward. I have passes for like Phong rendering, solid rendering, and I started working on PBR as well. I sometimes think of this as more of a engine framework, like something you use to build engines rather than prototype. But also, it's easy to prototype with the passes I have. Next. That here's when I wanted to show demo, but since I'm not sharing my screen, I guess.
I should be able to put you back on, I think, if you want to share that. We can take a look.
Okay. Entire screen. Do you see my terminal?
No, so it's still stuck on Firefox, it looks like.
Okay.
Yeah, interesting.
I guess it's just a bug. It's okay.
Like
you can just get the repository and run it. Since it's WGPU, you should run on your machine, so it should be fine. Next.
All right. Whoops, it is this one over here. All right.
Yeah. So it's probably impractical. I'm sure if you're just like building cubes on top of each other, you can take an existing engine and it's going to provide you very great opportunities to do so. But if you're toying with building your own pipelines and you need a solid foundation, then using the Baryon core may be interesting path as well. So that's everything.
All right. So super awesome to see this. From Connor in chat, we have, I love the idea of taking an entity component system and bringing it natively into the rendering engine. And so I don't know too much about like rendering engines, obviously on the same level that you do, but I thought that Bevy had sort of this idea where they were using parts of the ECS for the rendering engine, but could you like describe a little bit of the difference maybe?
I wish I knew the difference. I didn't dig into that Bevy so much. So, and I asked around, like, what's the support for custom attributes and so forth, and it looked like it's a work in progress so far. So, my understanding is that meshes in all of that engines so far in Rust are more or less like fixed in stone. Like there is a number of attributes that you know about, the engine knows about. Whether it checks for them or not, it still knows about them. And in Baryon, engine like core does not know about anything, does not what your position is even. So that's the biggest difference, I guess.
Interesting. I'm going to just go back a few tabs here to this architecture. And one interesting thing that I see here is like the node hierarchy being on its own as sort of a tree. If I'm understanding correctly, so I use the Godot engine quite a lot, and it has like a very structured scene tree. Is this sort of the idea that this represents, where every type of node is still in some type of tree and is sort of outside of the rest of the core?
Right. So the entities hook up to the tree, basically, and an entity can be your light source or your camera, and they hook up to particular nodes of the tree to know where they are. So this is similar to Godot, but I think some of the scene graph-based engines, they go a different way. Like you hook up nodes to entities, and then there is some restriction on like if your entity is an object, then you cannot have the light attached to the same node and so forth. So I chose the other way around, and I just hook up two nodes from entities.
All right. Well, this was super cool to check out. I'm definitely going to try building it later and just kind of seeing how some of it works. But I really like these kind of toys where you can play around with some pretty cool ideas here. Yeah, so this is super awesome. Thank you so much, Dimitri. And we'll be back in just a minute with Rusty Engine. All right, so we are back again here with Nathan, aka Clean Cut, who's going to be talking to us about Rusty Engine today. So Nathan, I'll hand it over to you.
All right, thanks. Can you hear me okay?
Yes, perfect.
All right, I'm not going to be sharing my screen today because I just woke up just a little bit ago, so it's early.
No worries, no worries.
Okay, so Rusty Engine. So let's see. Sorry, still waking up. So I'm Nathan Stocks. Like I said, I moonlight after my day job teaching Rust courses online, and I work on indie game dev projects as well. I actually created Rusty Engine for the students of my courses to use for projects in the courses. So Rusty Engine is a simplification layer around Bevy. We're talking about a lot of engines today. This is really cool. I like the stream today. Anyway, it's a simplification layer around Bevy, and it hides all of the powerful but confusing game engine concepts, because the whole point of this is to make something really simple that you can use while you're learning Rust. And I don't want people, my students specifically, to get confused by, oh, well, what's an ECS and what is this rendering stuff and all of that, all of the extra concepts that you have to learn with a game engine when they're learning Rust itself. So if you want a proper game engine, use something like Bevy, or there's a whole bunch of other good options. If you want an interesting sort of small toy game engine to use while you're learning Rust, this is a very niche product, then Rusty Engine is fantastic. So let's check it out. So let's get out of the browser window here. I'll just move that guy away. All right, so I have a couple things up already. But what I'm going to do is just give you a quick little tour of Rusty Engine and show you a couple examples, and then we're actually just going to write a little prototype, like just show it in use. So first off, let's show the kind of things that you can make with Rusty Engine. So I've got a bunch of built-in examples that you can run. One of them is this little road race thing. Hopefully you can hear the sound coming in through my mic. Hopefully it's not too loud. So this is just like a little prototype. It's 134 lines, including blank lines. So it's really, really tight, really short. Just has these obstacles on this sort of road, and you're just going back and forth and avoiding it. As you hit things, it'll play a sound. I'm not sure if you can hear it. Health goes down, and eventually you run out of health and game over. So really simple. There's not a lot of capabilities exposed, but the point is you can do something interesting, something visual, something audio with pretty much just plain Rust. Let's take a look at one more example real quick. This is called Extreme Driver Z. So this one, you've got this car that you're controlling, and you just need to drive around and pick up the little circles without running into anything else. So you got a little score there in the middle. It's counting up. You're going around these obstacles. And then, of course, if you hit an obstacle, it's over. Really simple. So there's a couple examples that are tools. So to create that Extreme Driver's Ed there, one of the useful examples is the level creator. And this just lets you pick what sprites. You can scale them up or down. You can rotate them and stuff like that. And then you place instances of them somewhere, however you want. And then you hit a key. And I know I need to implement sometime an actual like save, like a state saving capability. But right now I just spit out code. So you can just sort of go and copy and paste the code and then put it somewhere in your own project. So that's a level creator. The last example I'm going to show real quick is just we've got a collider creator, or the sort of the detection for sprites. You can bring your own sprites. You can bring your own sounds if you want to. You can bring your own fonts if you want to. But they're all included in an asset. There's a bunch of them included in the asset pack as well. If you do bring your own image and you want to actually collide with something, then you need to create a collider, and you just use this example. So you go get assets, you name your image. So let's say like a racing, let's do one of the race cars. What is it? Car, there you go, car blue PNG. And then we have this collider creator. That white line represents the collider. You can get rid of it and you can make a new one. That's a terrible collider, but so anyway, a bunch of tools that sort of help you set stuff up if you want to, or you can just use the built-in stuff. Okay, so that's it for like the examples. Let's actually show like a from scratch thing. So I made this a cargo new example, and I went in and just before the thing, I just put in Rusty Engine 4.0 as a dependency and did cargo run just to get stuff to compile. So we'd actually have time to see something. And let's just go make something. So let's go into main.rs here. Okay. And then let's go ahead and get rid of this boilerplate. So for Rusty Engine, it's designed to use the prelude. So use Rusty Engine, prelude, all of it. Okay, and let's make some game state. You can have one game state struct. You can name it whatever you want, but I usually just call it game state. And let's just have, we're gonna make like a little shooter. So we're just gonna put some sprites on the screen and have something shoot a marble at them and collide with them. And maybe we'll get that far, maybe we won't. if you just want to let me know when I hit time, we'll stop if we're going long, or maybe we'll get it all done. So let's just keep track of a score and a unique ID for like our marbles that we're shooting, because we need unique labels. And I'm just going to call it U64. All right. The main way we get we interact with Rusty Engine is through the game object. So we're going to make a game. So game new, and then we're going to do our setup, and then we're going to go game run, and we're going to give it our game state object. So the whole point of this is to let people like learn Rust. So they get to make structs. They can do things like, okay, well, let's get a default. So let's do, in this case, a derived default would be just fine, because zeros is exactly what we want. And then we could say, okay, game state default, right? Or you can make one explicitly like this. There's all that different ways you can approach it. So that's enough to actually start running things. Give some warnings that we're not using things, but that's done the setup. And oh, it's not enough because we didn't download the asset pack. So one thing that's, it's not bundled inside of the crate. You have to go get the assets. So let me just go grab that real quick. I've got a bunch of instructions. I've got a full tutorial. I've got a quick start, all sorts of stuff. And you can copy that command out of there, get the assets. Let's go run it now. Okay, so we got our blank gray window, right? Not very interesting, but it works. It was only a couple lines of code. We've already got our state set up that we're going to get. Let's work on our logic. So we're going to make a game logic function. This is like the last boilerplate that we have to deal with. This is going to return a Boolean, and it accepts, or it passes you an engine state, which is a mutable reference to an engine state. And that basically represents the whole game. That's what the game has under the hood. And that's what it's going to be passed each time. Each frame, this function is going to be run once. And then if you pass it a game state, you get a game state as well. And then that's going to be mutable reference to your game state struct. So we've got our engine state, our game state, everything's packed up in one of the others of those. Game state for stuff you make, engine state for everything else. Great. So now we need to tell the game what our game logic is. So game add logic, game logic. Great. You could also do it with a closure, but I don't think that's very ergonomic. So let's just do a full function. So right here, we need to do our setup. It's like setup stuff. So what do we want to set up? Well, let's see. Let's make a little gun-like sprite, right? So let's say game. We've got an add sprite. Okay, so every sprite gets a unique label. So this is going to be our player. So I'm just going to call him player. And then you can either give it a path to a file, but we're just going to use presets. So we're going to sprite preset. Let's use our racing barrier red. It's sort of a rectangle. I'll show you in just a second. And then let's go, okay, that returns a mutable reference to a player, well, to a sprite rather. So let's say our player's rotation is up. There's a bunch of constants for direction, so up is one of them. Player scale, let's set him to a little bit smaller. So we're going to scale him down to half size. Let's take his translation, which is in a 2D coordinate system. I actually unified the UI and the in-game coordinate systems to be the same 2D coordinate system with vec2s. Let's just set him down near the bottom of the screen. And let's set him on a high layer because the marble that we shoot is going to come out of this thing. Okay, and that's enough. We've set a sprite and we've got a game. We're running this thing. We need to actually return our Boolean. That tells you whether or not to process the next game logic function. So you can do things like menus and pauses that like cover something up or stop something else. And that should be enough to see a sprite. Okay, so there's a sprite representing like a gun barrel. We're just going to set a bunch of sprites on the screen, and then we're going to have this like shoot them with marbles. And that's all the game prototype is going to be today. But let's get that stuff set up. So let's go back to that level creator example. Let's just pick something, some cars, some some of these. What else we got? Oh, sure. That, and that, and that. Okay. Okay, the key here spits out. I'm just going to copy the, I don't need that anymore. Just going to copy the sprite placement portion of the example code here. And we're just going to plop it in right there. Save that, reformats. Run that again. And voila. Okay, so there's all the stuff. Now we got to make it work. So now we're down on a game logic. We're doing the actual game implementation. We're halfway done. All right. So first thing, let's make that, that little player gun barrel thing. I really should be making this bigger. I apologize. Here, let me. Wait. Okay. So the player gun barrel thing. Let's go ahead and go. So we get that out of the engine state. So, and we're going to save a reference to it. So engine state has a hash map called sprites. That's where all the sprites are. There's only a couple primitives in this engine. There's sprites, there's text. I guess that's sort of what lives in the world. Sprites and text. You can also play sounds and get other state, but that's really what you're operating on. So we're going to use our get mute, which is a regular hash map method. We're going to, the key is the label. We called it player. We know it's there because we hard coded it to be there. So we're just going to unwrap it. And then we could say, so the mouse location is an engine state mouse state location. Now that's an option because if the mouse isn't in the window, you won't have one. So we're going to go if let some location equals that, then we have a mouse location. So if we do have a mouse location, let's set our players translation X to the location X. All right, and then I want to save that X location for later. But one of the drawbacks of sticking everything in a huge struct is you have to deal with trying to access stuff of it from different parts of the struct at the same time. So sometimes you have to sort of like copy things out like this. We're going to use this later. But let's go try it out. Oops. Go and release. Okay. So now it follows our mouse. So now let's make it shoot. So we are like almost 3/4 of the way done with this thing. So if engine state mouse state just pressed our mouse button left. Okay, so we just pressed the mouse button. That's what we're going to use to fire. So we need to create a new marble. Marbles need unique labels. So we're going to make a label first. We're going to say we're going to format a string. We're just going to start it with marble. And then we're going to give it that game state's unique ID. And then we're going to increment the game state's unique ID. So it really is unique. And now we can make it sprite. So let's get a marble. Our engine states add sprite. The game actually implements deref mute and deref on an engine state. So most of the things you call on the game object are actually methods of the engine state, like add sprite. So give it that label. We'll give it a sprite preset. What should we use for our marble? Let's use the rolling ball blue. All right. So now we've created the marble. Let's place it in the right place. So marble translation, we want to be down by our little player gun things. Like all the positions in Rusty Engine, it's a vec2. So make a new, we want to put it on the player's X. That's why I saved that up there. Your integers are copy typed, so that copied that out here. So we didn't try to access something inside the engine state while we were accessing something else inside the engine state. We want to put it down by the player. So that's sort of a fixed Y. We want it to be under the player, so we're going to put it at a lower layer. So let's put it at 5 instead of 10. We want it to collide with things, so we have to enable collision so that it's actually opting into the collision system. And let's play a sound. So that engine state has an audio manager, and you can just play sound effects. Go. Let's do a sound effects preset impact 2 and a volume of 0.7. Okay, so that'll set the marble down by the player. It won't actually, we're not moving the marble yet, but it'll set it. So let's go see it. It should play a sound too.
And unfortunately, I will have to cut you off after this one right here.
Okay, that's just fine. I thought we might not make it all the way through, but the final logic is we just make the marble go up, and then we detect the collisions and have it do something. And
yeah, when you said that the like the car demo was like 134 lines, I found that pretty interesting. Like that's definitely pretty concise.
Yeah.
What I'm sort of wondering is, like, since you built this as a way for your students to get used to Rust and play around with it, how have you found that they've been able to sort of explore more, or like explore their own ideas? Like, how easy is it for them to sort of be creative?
Well, I hope it's really easy. The difficult thing for me is that these courses I'm doing are either online on Udemy or I'm doing them for live presentations with O'Reilly, but I'm live. They're webinar mode. The only interaction I have with them is the text chat during the presentation. So I get very little feedback about how people are actually using it. They seem to love it while I'm doing the presentation. I get a lot of questions, and the feedback after I'm done is good, but I don't hear a lot about what people do with it. So I'd really love to hear that. If someone listening uses this, please let me know.
Awesome. And then on that topic as well, what I'm sort of wondering is, since this is a Bevy derivative, does that mean that someone can use this in the Bevy jam that's starting in about 2 weeks?
I assume so. I don't know that, but I mean, it does directly. I mean, it just does use Bevy. And I mean, you can even sort of peek around the hood, so you could actually access Bevy. You might have to fight the engine a little bit for it, but yeah, it's all Bevy.
Yeah, okay, because that could be pretty cool. I played around a little bit with Rust Engine a few weeks ago, because I'm like, when I go to do game development, especially in a jam sense, I definitely think in terms of constraints, in that there's a whole world of possibilities of what game you can create when you sit down. But as soon as you can start constraining yourself to work within a small amount of room, then it becomes a lot easier to have a path forward, because you're just not allowed to do stuff outside of that. And so I think it's definitely really cool to see that the path to getting a car to drive around, or sprites to be on the screen, is very, very minimal. And so I definitely see a lot of prototyping potential from this. So that's very cool.
Cool.
All right. Well, thank you so much, Nathan, for showing this off. And I'd love to maybe see you come back. If you know of anybody who has made any games in Rusty Engine as well, definitely having them show and tell what they've been working on would be great as well.
Okay, absolutely.
Cheers.
Thanks.
All right. So we are back here with CW Fitzgerald, who's going to be giving us an update on Ren 3 alongside Setzer 22. So I'm definitely excited to see what this is about.
Yeah. Can you hear me okay?
Yes, perfect.
Wonderful. I love the hold music. It's amazing. All right. So, welcome. This is another monthly update on Ren 3. All right. Okay. Yeah. There we go. So I am extremely proud to announce that Ren 3 0.3 has finally come out. It took us about 3 months to get it into a state that was really something that users would actually uh, be able to use well. It just so happens that at the commit after the release, because I fixed the issue in the README, happens to be commit 1000, and I just thought that was very beautiful and pretty. So, yay. It's been a while. So just to go over the the major features that have come out since 0.2, we have redone how we use how we do rendering and how we can oh man. We now have a render graph that you can use to do customizable and composable rendering passes. So, for example, we have a separate depth pass that runs completely independently from all the others, and you can extend that in various ways. We have an eGUI, we have an ImGUI integration. We now have vertex skinning and animation, which we'll get to in a bit. And we support left and right-handed coordinate systems and about 1,000 other things. There's a full changelog on the GitHub, and if you're interested, go take that a read. In addition, this was actually there for last release, but this has improved significantly, so I want to explicitly call it out. We have a standalone GLTF viewer that is published on Crates.io. You just cargo install Scene Viewer, and it will give you an application that you can point at a GLTF file, and it will do its best at rendering it. There's a bunch of command line options for customizing lighting, how to interpret the GLTF, because basically no model is up to spec. And we support a lot of the a lot of the features of GLTF. Not all of them, because some of them are a little insane. No animation support in Scene Viewer natively yet, but that will be coming soon. And the biggest, and for me, the most exciting announcement of all is that we have a new teammate. Setro22 has joined the Render 3 team. They worked on animation and vertex skinning, and I will actually pass it over to them for a live demo.
Hey, thanks. Oh, yeah, my infinite recursion screen. Okay, thank you for the introduction. So a bit of background. So I've been working as part of my job with we're building a Rust game, and so for that, we've been looking for different technologies that could help us, and yeah, Ren 3 looked like a very solid option in terms of getting a render that's both customizable and also has a, let's say, a down-to-earth API that we can understand and modify, because that's something that we're probably going to have to do a lot of the time. And so we started collaborating, things went nice, and so, well, we decided it's time to implement animation. So yeah, I asked Connor about it, and he's been super helpful, and yeah, been very patient with all my questions, and we've came up with something that I believe is pretty nice. You can see it right now, hopefully on screen, I believe. So, okay, this is the animation example that's now shipping as part of Ren 3. And basically, this is a GLTF loader model that we have with some XAML animations. But basically, you can load any model just like this in the example, and mostly animations should work fine. The code is not very complex at this point for the animation. We have keying is part of the core engine, and then the animation is just a helper crate that's on the side that doesn't handle a lot of things like animation blending or animation trees yet. It's just the basic things just to showcase how you may get started with this, and I believe it turned out pretty nice. So on the implementation side, we've been well, we were discussing, well, pretty much. Father told me this idea, and I agreed that it was a pretty nice approach. The skinning is being done as part of a compute shader instead of doing it on the vertex shader as is like the legacy approach, let's say. And in this case, what we are getting out of this is that if you render the scene from multiple points of view, just like when you are doing shadows or things like that, you are running skinning only once per frame for each of the vertices. And yeah, this is a nice optimization. On the other hand, of course, it's using a bit more of the GPU memory, but yeah, it's a trade-off that many games are taking nowadays, and yeah, we believe it's turned out quite nice. So, well, yeah, that's all from my part. Hopefully, you enjoyed the yellow dancing guy, and yeah, I'll pass it over to Connor again. Thank you.
I have seen that a lot at this point, and it never ceases to just be awesome. I love that so much. All right, so a little bit about the future. Obviously, 0.3 was a very big release for us. There's a lot of stuff going on, and there is still ever more stuff going. No promises, of course. We do what we can with the time we have. But these are the various things that are on our mind that we are going to be looking at or prioritizing. First is work inside of WGPU, actually. A lot of Ren 3 itself relies on a lot of features that work and but don't have the safe implementation implemented yet. So a couple of the things, DX11, that's a pain point for WGPU as a whole, but a very surprising amount of people actually don't have support for either DirectX 11, or DirectX 12, or Vulkan. So we want to make sure the DX11 backend is up and running and functional. And in addition, Ren 3, because of the way it does texture binding, actually basically binds every single texture you have in the entire scene all at once. And this is fine, but it has pointed out some bottlenecks inside of WGPU with regards to tracking performance. Tracking is making sure textures live long enough and also generating barriers so that everything is working correctly. So we're looking at improving performance there, going to do into safe resource indexing, subgroup ops. There's a bunch of things we want to add to WGPU, and of course, because this is work on WGPU itself, everyone will get to benefit from this work. On the Ren 3 side, some things that we're thinking about is pixel perfect object picking. So mainly object picking is done on the CPU if you want some very coarse things, but if you actually want the exact pixel to line up, the the easiest way to do this is almost always with the GPU. So figuring out how to make the Ren 3 framework flexible enough to be able to do that and implement it itself. Particle systems and billboarding. Particle systems, because they're basically either quads or triangles or what have you, lots of very, very small meshes. There's a completely different rendering, basically, style that works efficiently. So we want to have that as a bespoke piece of the Ren 3 pipeline. And finally, and this is the most ambitious one, is we want to move to a meshlet-based pipeline. This will give, not mesh shaders, mind you, but just meshlets in general. This will give us the ability to implement a lot of really interesting performance optimizations. And triangle culling, we want to have all vertex attributes be optional, and you can add extra ones. This actually goes back to what Dmitry was talking about, that being able to say, oh, this mesh has a position and a thing, but we don't actually care if it has vertex weights. So we want to be able to do that, and there's a ton of optimizations that comes along with that. But it is a very large challenge, particularly around managing the vast amount of data you need in an efficient way. So I'm working on that. We'll see how much of that ends up coming to fruition for next release, but that is what's on our mind. Finally, if you want to use Rend3 or contribute to it, please come join our Discord or Matrix. There are links in the README of the repo. And yeah, and just finally a couple shout outs. Of course, thank you so much for pardon my dog, to Setzer22. And yeah, so shout out to Clark for pointing me towards HackMD. These are for the slides. These are really cool. And thank you to Eclisma, Rob Swain, and the entire Bevy crew. There's tons of really interesting, illuminating discussions that go into that happen on the Bevy rendering server. And yeah, thank you to everyone who contributed this release. And yeah.
Awesome. Always cool seeing. And I think it's been anticipated for a few months having 0.30, right? Like this has been something that's pretty big. Yeah.
Oh yeah, I announced two meetups ago that Rend3 0.3 was about to release.
So it's finally come out. That's awesome.
Yeah, it took a little time to bake, but I'm very, very glad we did. The result is so much better.
Mm-hmm.
I'm super happy with where we are.
Yeah, and I think as well that idea of being able to sort of give back by working on WGPU, I gotta say, like we use WGPU for Valorant and I love it so much, and it's like such a great ecosystem. I mean, I don't touch it so much, but the people who do are doing some really cool stuff.
Yeah, it's definitely, I'm very happy that the community has gathered around WGPU as the way we do rendering in Rust.
Mm-hmm. Yeah, a really solid stack to be able to work off of. And also I do want to say, yeah, HackMD. I started using it because I saw like the Rust core teams were using it for their meetings, and oh my goodness, it's so nice being able to write Markdown while you're giving a presentation and just reload a page. And it's a very good way to do stuff. So I definitely can echo that sentiment. Yeah, so this is super cool, and I'm also very excited to see that Setzer22 is helping out with some of the stuff. We have Setzer22 coming and giving a talk. Giving a talk in 2 talks from now or something like that. So I'm excited to see that as well. And I expect we'll see some improvements on Rend3 next month as well.
I hope so.
I hope so as well. All right. Thank you so much, Connor. And we'll see you then.
See ya.
All right. So now we are back with Elias, aka Tarash, who's going to be talking to us about some recent changes to Dotrix.
Hello everyone. I'm owner of Leavenware company, and Dotrix is our product. The rest of the time we are doing some third-party development, but we decided to create our own game engine in Rust, and as a result appeared Dotrix. It's here for more than a year already, and today I will show you what is new in this engine. So we've been working on rendering stuff mostly, and thanks to contributions of Andrew King, who joined our team and did a lot, we did something weird happens. We did re-implementation of our material component, and right now Dotrix supports various configurations for materials. For example, you can have metallic materials, mate, glance, and affect also how ambient light affects your material, your body, your model. The next big thing was normal mapping, and it is finally here. We support normal maps for materials. And one of the most interesting and most massive part was compute shaders. It actually affected our renderer part a lot. We changed the way how we use buffers, how we use meshes, and finally, Dotrix have support of compute shaders. So you can make some calculations on GPU side in compute pipelines and pass these results into a vertex shader. And on the screenshot, you can see example of particles system. Right here is about 2,000 particles, this 2,000 cubes running on 60 FPS on Intel Iris, on MacBook. Also on the same card, I rendered about 2 million cubes. It doesn't look nice. It runs at 30 FPS, but for integrated card, it's quite well. On NVIDIA card, it runs much better. I will show this example in the end of the presentation because it really looks beautiful. Right now, I just want to mention several more smaller things. As I said, we have new contributor, Andrew King, who did a lot for this rendering stuff. Also, we had contribution from Russell Wong, who ported Dotrix to iPhone. We did measure refactoring of meshes, and at this moment, meshes in Dotrix can have any set, any amount of any attributes. Everything is optional. You can choose whatever format you want for your attributes, set of attributes, and define any layout you want. We changed the way how we use camera and actually renamed some misleading properties. Now we stick to pan angle, tilt angle, and roll angle, and together with distance, it allows you to easily use camera in, I would say, 2 modes. First of the mode is like, if we speak about third-person gameplay, you have a target and you have a camera around it. So if you turn around your target, it's a pan angle. If you go up above your model, it's tilt angle. And if you just roll camera around its directional vector, then it's roll. And if you switch distance to some very small value, then it works like classic yaw, roll, and pitch mode. Also, we implemented default path for assets. Now you can have assets in some predefined folder and just don't care much, don't use some absolute paths and so on and so on. We, as I said, refactored renderer a lot. Right now we have universal buffers for vertex buffer, indices buffer, for some uniform buffers, storage buffers, and the only exception is texture buffers, which are a little bit different from them. Also, we extended ECS with several necessary functions. These functions should be there for a long time already. Finally, they are a part of our engine. So what we are working on now, it's second part currently on the table. We are trying to implement GPU-driven rendering, like indirect rendering with huge buffers when you put several meshes into one storage buffer and render them indirectly on the GPU. We finally started to implement our own low-poly multiplayer game. And at this moment, we have 2 developers who are working on this, not full-time, but still. We have a 3D modeler who prepare assets for this. We are also preparing website, handbook, and we are about to start with video tutorials for Dotrix in nearest future. And about future, there is one big thing that changed in our company. We started to cooperate with a Czech startup incubator. It is called Lipo Inc. And they're about to help us with networking, with finding investments for our project. And they actually should help us to turn our project into a product. And I'm very happy about it. Looking forward new challenges, new requests that we'll have from them, from, I don't know, potential investors, from our potential customers, and very, very, very positive about this. And that's it from me for now. If you have any question, I am in Discord and on YouTube transmission, so feel free to ask anything. Thank you.
Awesome. This is super cool to see some of these recent changes. I think one that I'm particularly interested in is getting it to build on an iPhone. Do you know much about the process behind that? And if there's any limitations right now, or does it work pretty nicely?
There were some limitations which we already fixed. It was about the assets paths. I think there is a repository on our GitHub with implementation of this port. We use this cargo mobile module for this, and it just works. It doesn't work on Android. I tried it. It requires some additional efforts to find out where the problem is, but it should be straightforward.
Awesome. Yeah, so that's definitely super cool to see. Also, with this, you described like the low poly multiplayer sort of RPG that you're building, and so going into that, or is this some of the stuff from that?
No, this is the compute shader in action.
Okay.
Particles.
Yeah,
I promised to show it, and it's probably better screen, better wallpaper than.
It's pretty cool. It's pretty cool. So like with this like low poly multiplayer game that you're going for, I'm assuming it's not open source, right? It's like a internal development that you're working on.
At this moment, yes. At this moment, we are keeping it privately, but we are sharing a lot of solutions, like common solutions that can be reused in some other projects as a part of Dotrix, and that was the plan from the beginning. Mm-hmm. So we will mostly isolate the game logic, the networking logic, like not networking in general, but the protocols and other stuff. And the rest of the tools will be public. And I think based on this, there will be also editor application that will be public.
Mm-hmm. All right. Well, thank you so much for the updates. I hope to see you here in future months giving us some progress updates on the low poly multiplayer game. Yeah, I think definitely being able to, well, as someone else mentioned, we're seeing a lot of engines talking about like what progress they've been making. And it's really cool seeing the progress, but also like what's being built on top of it. So that would definitely be very cool. So thank you very much, Elias.
Sure. Thank you for the opportunity to present it.
Absolutely. All right. So hello. We are back here with Setzer22, and this is a presentation that I'm very excited for personally, just because I've been editing the Rust Gamedev newsletter for several months, and Setzer22 is always someone who's come in and shown off some very, very cool stuff that is like a genre of game that I quite like myself. So I'll let you take it away, Setzer22, and tell us a little bit about the process.
Okay, thank you very much, and welcome to the process behind the process. So this is this game I've been working on, which is basically a factory simulator, factory builder kind of thing. And well, the game is essentially pretty much inspired by Factorio, Satisfactory, Mindustry, and similar games of that kind. There are many once you start looking. And anyway, what I'm trying to go for here is something that's probably a bit more lighthearted than all those other experiences, and also trying to appeal more to a slightly more casual audience. I'm trying to make something that's more simple for players, but without taking away the fun that comes with creating intricate factories and building automations and stuff like that. And so what I wanted to do today is, because it's my first time here, was to make a bit of an overview through the history of how I got there and why I'm using Rust as well, because it didn't start like this. Actually, it started pretty much like this, as you see. So this is pretty much the typical side project story everyone has gone through. One day I wake up and say, okay, I'm bored, I want to make a video game. And I decided that a factory builder game would be kind of cool. So I started working on that, and I fired at Unity, and 40 minutes in or something, I decided I did not want to use Unity anymore because I hit 3 different Linux books for the editor in like a very short session of work, and said, okay, I need to look for something better, something that supports my workflow a bit better. And that's when I started looking, and I came across Godot, which is a wonderful game engine, fully feature-packed, pretty mature. I mean, has like more than 10 years of development on its back. So, I knew I would find in there pretty much everything I wanted to find to make my game, because I didn't know much about game dev then. And I started building things. And as you can see here, right from the very beginning, this is like first to second week of development, I tried to follow this GIF-oriented or GIF-driven development, as I like to call it, which is very much recommend this. It's basically worry about making cool GIFs to showcase to your peers because that's fun and it brings you joy. And this is what game dev should be about. Of course, maybe I wouldn't get the best architecture by going like this, but it also helps a lot of iterating fast, trying new ideas, see how it works out. And as you can see, also from the very beginning, I already tried to come up with some nice saturated colors for the art. And well, this is pretty much how things started. And I kept building things, and this was the first appearance, the first time I decided to show it to the general public. I went to Godot. I mean, at this point, I wasn't using Rust at all, so that wouldn't have made much sense going anywhere else. And maybe the most important lesson from posting this is that if you're making a factory game, don't make your main GIF be about a guy planting carrots, because people are not going to get that the game is a factory game, and you'll get lots of questions. But well, I just decided to double up on the carrots and make a full factory out of them, and that's what I continue doing. And this pretty much like a month and a half, 2 months into development, where I started building all the main aspects of the factory simulation. And this is all GDScript at this point, by the way. The GDScript is this language that the Godot game engine is using, and well, it's probably nice for beginners. It has a very much dynamic sort of feel, inspired by Python, but it also carries over some of the C++ complexity, paradoxically. And well, basically, factory was growing, but so was the code. And I actually went back to my Git repository today just to fetch this screenshot, because this is the exact commit that made me go, okay, I cannot do this any longer. I was trying to do a little refactor for the for the code in the simulation, the thing that's moving items along the conveyor belts and entering inventories on machines and things like that. And I just wanted to add like a new field. So I had to wrap something that was previously a string into some kind of struct. Just that in GDScript there are no structs, so you only get hash maps. So I started putting everything into that hash map, and it took 4 hours to do that refactor because GDScript has no types and very bad IDE support. And after those 4 hours, I spent 3 full days debugging because it led to all sorts of crazy issues. And I knew I was pretty much alone if I had to do any other refactor like that. And I knew there were lots of refactors coming. So this is where it gets interesting. Rust to the rescue. I decided to use Rust together with Godot, of course. Mainly, Godot, of course, for everything I've said, I did not want to change engines. It was just the language that was kind of driving me nuts. Because the Godot is mature, feature-packed, and had mostly everything I needed to make a game. And batteries included. I don't need to worry about some feature not being there. I just need to worry about my game logic, the things I want to build. And then I started looking for languages because Godot has this nice thing where you can integrate any language on top of it using this GD native tech. And there are bindings for many languages. You get NIM, you get Python, you get, of course, C++. People have done it, I think even probably for Java and Zeek. Everyone's there, and so is Rust. But when I look through the bindings, the Rust bindings stood out because they were very carefully crafted, and they were very nice on using a very clever use of macros, let's say, to take away the boilerplate. That's the main thing that stood out to me. It got me like very good IDE support, just like it was a native thing from the engine. All the types, all the functions were there. I had autocomplete. It felt pretty much like it was something that was straight up supported by Godot, and of course that's only possible because of the amazing people at the Godot Rust repository who have built these nice building bindings. But yeah, I started using this, and of course Rust also, as a newcomer to this community, I must say that you have done a pretty good job about being noisy and letting other people know that Rust is great. So that's I already had Rust under my radar, and I knew it would help me make safe code, no segmentation faults, which are an awful thing you get when you do game development in C++, and fearless refactors, which was what pretty much what I was looking for. And most importantly, the types. I was missing the types after probably 5 or 6 years working like professionally in software development in purely dynamic languages. I was missing the types. Let's say I was missing a compiler telling me that this thing that was I'm expecting it to be a string is actually a hash map. So the methods in there are all different, and yeah, having to run the game just to figure that out once some random line of code triggers was a very painful experience for me. And this is what Rust brought to the table. And notice that in my analysis, performance was actually never a consideration. I knew I was able to build this thing in GDScript purely from a performance point of view, because the game I'm building is actually not that performance sensitive. Even though there's a factory I need to simulate there, I'm not planning for a game where you can build massive factories. It's a more self-contained experience with tiny maps and more, not want to say puzzle, but a bit more puzzle-like. So yeah, I wasn't really concerned at all about the performance because Godot is already handling most of the heavyweight parts like rendering and all that logic. So yeah, even though it was not a consideration, I'm very happy to have chosen a language where performance work is so simple, let's say. So yeah, I believe with time now for a short demo. I want to showcase a bit of the current state of the game, which we've seen how the game looked like probably more than a year ago. Let's see how it looks today. This is the main menu screen. I don't showcase that often because it's not very shiny, but yeah, I got this going. You can also load and save games. I've been also working a lot on the infrastructure behind the scenes. And yeah, hopefully there's this. Sorry about that. Okay, and was getting some audio from the game. Okay, so this is the process. I'm inside of this test island, and yeah, let's go to that factory up there, which I built before. And yeah, we could walk, but it's a grappling hook there for fun. And yeah, you can see here this guy is chopping wood. It's just a placeholder for now. The wood is getting cut into planks and feed into this assembler machine, which is creating these machine parts, which are like bolts and gears and wood, which is just an intermediate item. And here we get these guys, which getting the rest of the materials. They're getting iron ore, which is grinded into a powder, which is then smelted into ingots, and yeah, that creates the whole thing. So basically, that's what we have. You can build these factories, and then the game. What the game has you doing is building a factory to fill like a certain quota. Like you can see up here, it's asking you to collect as many items, and there's this resource management going on where you need to decide how many items you can get before the time limit and the resources run out. So I wanted to showcase a bit to the building of the factory, and so let's get in there. So let's collect a bit of wood from these trees and get it into the core of the factory there. That's also a placeholder model, by the way. It should be like some kind of bigger storage. And yeah, let's grab a few tools. This is, by the way, it's all done in EGUI. I'm doing this experiment where I'm using EGUI for game UI, not just debug UI, which is what everyone seems to be using EGUI for in games. But yeah, I'm trying to build the UI with the game with EGUI, and so far it's been a pleasant experience because even though Godot has a perfectly valid UI system, I like EGUI because it's more tailored to the whole Rust experience of being data driven, having types play into the thing. Otherwise, I would just be casting everything into transforming everything into Godot hash maps and doing some very unergonomical things just to get some UI. Whereas EGUI feels like pretty much fits my game perfectly. So let's get an extractor and something to cut the wood. Let's also get conveyor belt and some things to build the floor. Actually, not that. And let me build. Let me get also a merger. I'm going to need that. And yeah, so you build your toolbar, and then let's add the wood here. Start building this balcony. Let's copy some extractors. The extractor is just going to have different model for depending on the kind of resource that's extracting. But for now, we get this cool dude here, which need to be very focused on his job. Okay, and yeah, let's put down some conveyor belts. Merger here, which should be connected, which we can then hook into another merger here to get our wood. No, sorry, our wood down into the factory. Let me just build somewhere here below where we can put our things. No, and we need a ramp. Okay, there we go. We can get our wood. And finally, we just need to, cut it into planks and feed it into the factory. And hopefully everything should work now. Yeah, you can see we're getting the logs in there and feeding it into the factory. And you can see this number go up. It means everything's working. Yeah, so this is the process. I mean, there's lots of things that I'm not showing here because I've been iterating on this game for a very long time. I've kind of taken the idea of reducing the scope a bit now. So I've been probably showcasing a lot of things that may not get into the final game. This is pretty much where I'm going now. And right now, most of the core systems are in there. And I want to keep iterating by adding a lot more content and try to see where this goes. And yeah, hopefully it should be a very fun experience to play. So yeah, this is the game, but there's just, oh, sorry, not this. Oh, let me go back to the presentation. Yeah, there's just one more tiny little thing I wanted to share with you today. So a game is not just code, and behind the process there's also like a ton of art that I need to do, and I've been doing well, apart from some very helpful collaborations, I've been mostly working on the art myself. So what you can see here is that the art for the process is very much procedural. I've been using Houdini and also lots of similar tools just to speed up my workflow and get an art pipeline that's non-destructive. So I can always go back and revise my design decisions. Also get very precise control about how things are, because you can imagine making all these machines carefully fit together is something that you need to do very carefully. And so, yeah, you're telling me this is all procedural? Always has been. So what I wanted to say is that I'm very happy with this art pipeline that I came up with, but now that I need to really step on my game and start to create a lot more assets, I've started to realize the shortcomings of the current 3D asset generation pipeline, basically for video games. And yeah, this is why for the past few months, I've also been working on this Blackjack project, which I will not have a lot of time to showcase today, but I wanted to get this tiny sneak peek. Essentially, I'm trying to build something that's, unlike other 3D modeling tools, is very much suited to game development. It's procedural and it's for low poly assets. So basically, exactly what I need for the process. I want to get it something that's more custom built and fits my needs. And this is what I've been working on, besides from the game for the past few months. And it's I believe it's coming along nicely. I've been learning a lot, and stay tuned for more news about Blackjack. Hopefully soon. But yeah, I mean, basically my idea is to dog food this into the asset creation process for my game, and I want to get very fast iteration. That's the goal here. So I want something that essentially frees me from this feedback loop of you are looking at your model in Blender or Houdini or any other modeling tool. You export it to the engine. You go through some kind of export process. Sometimes it's a bit lengthy. And once you see it in the engine and realize that it doesn't quite fit the art style you were going for, because of course what you were seeing on the 3D modeling software is not exactly the same, then you need to iterate again. And this is getting very painful. So what I'm doing is building something that can essentially get hooked into a game engine and just allow you to live edit these procedural models in real time. And well, basically what I'm building here is something that's entirely built on Rust. You can also notice that I'm using EGUI in there. And I've been also using Rend3 for the rendering, which of course sits on top of WGPU. And yeah, it's very nice technology. I'm very happy with it. It's a bit more low level than what I've been used to, but it's quite nice. And people have been nice and patient with my questions so far. So I believe I can get something nice going on with this, and hopefully inspire someone to create a better asset pipeline for indie video games. And yeah, this is essentially what I'm up to, and this is everything I wanted to talk to you today. So thank you for listening. Yeah.
Awesome. This is super cool to see, and sort of diving into the process and looking at this. One thing that your main menu had that I hadn't really thought of before is that it described it as a carrot cake factory, and I love that idea so much. Like that, just like because you see carrots, you see a factory, but then you have this idea of like a smaller factory that's constrained. And if you say carrot cake, I'm like, oh, I know exactly what this game is going for, and that is super cool.
Thanks. Yeah, actually, we can make carrot cake. I should have showcased that, but it was a bit messy to rescue that code. But yeah, definitely it's going to be there.
Nice. I also really like this idea of GIF-oriented development that you described, where like the point is to have stuff that you can show off, and so it keeps you accountable to people who want to see what the progress is, because you can like show off how stuff is going along, and then you don't get caught on just like a whole bunch of backend systems that don't see the light of day, or rather people can't see how the process is coming along. And so that was a really cool way of thinking about it. And then I was also going to say, with the like this modeling system, I was going to ask you about how you came up with a lot of these assets, because the process, it has similar aesthetics to me that like when I play My Time in Portia, it's like this game on Steam. You're kind of like doing stuff around an island. It has a lot of the same sort of look and feel, I think, and as well being able to sort of model a lot of these assets in a way that makes them look like pretty small, pretty abstracted from what they are. So like I really like the woodcutter. You can see it going up and down and chopping a little bit. It's a very nice way of doing it, I think. So this was cool to see the process here.
Yeah, thanks. Also about that, huge thanks also to my girlfriend, who's been helping with the designs of the machines. So she's credit goes to her as to this thing you were talking about. I also like a lot this idea of machines being abstract and simple, and just I hate when games of this kind, every machine looks the same. So you walk across your factory and you don't even know what you are looking at, and you need to click on a machine to see what it's doing. I like for machines to be like you can visually see everything that's going on. And I'm quite happy with that.
It's a very nice polished layer for sure. I definitely feel like when I'm playing Factorio, I'm definitely like a coder who's looking through to try and debug the specific thing that I'm trying to do. Whereas where I look at the process, it's a lot more of a like elegant way that I can see how stuff is moving around and stuff like in the form that it's in. So like the carrots look like carrots, and the conveyor belts are large enough so that you see the objects that are on them in a lot of this.
Thanks. This is all in the so I'm happy that you say that, because these are all conscious design decisions that I made. So
they're definitely coming through for sure.
Thanks.
I think especially like having seen just the pictures of this game in the newsletter, and so I can sort of assume some things about it, but as you move around the world and as you interact with stuff, yeah, it has a lot more of a feeling of like a lot of contraptions being put together, which I think is, I don't know, it really hits on the aesthetic that I think does really well for what the mechanics are. And so it's definitely like, yeah, the work that you put into it for making it look like this is definitely paying off for sure.
Thanks.
All right, so we will be back in just a minute with Kevin, who's going to be talking to us about Graphite. But thank you so much, Setzer. It would be really awesome to see more about Blackjack in the future as well. I think it seems like this this project can have a lot of potential. And I mean, also you see node graphs, you play around with it, and you're like, wow, I can make stuff with that. That's a cool idea. So it'll be awesome to see.
Thanks. Yeah, stay tuned for that. I will share.
Perfect. All right, so we are back with Kevin, and this is a very exciting thing. So we've talked about a lot of engines today. We've heard about the Ren 3 release, but Kevin, I will leave it up to you to tell us about what really big stuff is happening with Graphite right now.
All right, you can hear me, right?
Yes, all good. Yep.
Awesome. Okay, so we're very excited to announce Graphite Alpha is finally entering, alpha stage. So first, real quick, what is Graphite? So it is basically trying to be the next generation graphics editor for everything 2D. And here's a quick mock-up of what it will look like in the future. It does not look like this at the moment because it does not do graphics editing for raster, like photo editing, that kind of thing yet. But it does focus on it does focus on vector for this first stage of alpha. So Graphite at a glance. Basically, it's aiming to be a versatile, professional, and user-friendly 2D graphics editor for everyone. And kind of inspired by Blender, which has managed to basically infiltrate the market as the software for everyone in the 3D space. We are aiming to do that in the 2D space. For the raster-based image editing, we want to be able to do basic general-purpose image editing, digital painting, photo processing. I'm a photographer, so I really would like that feature to actually be able to edit photos with more of a procedural approach, and then as well as procedural generation like you might get from Substance Designer. You can think of it kind of like we're applying Houdini, which was of course talked about in the previous presentation, applying some of the concepts from that to more traditional 2D image editing. It's also a vector-based illustration and graphic design software, and that's what we're focusing on first for our alpha release that is now available. We also then have the node graph that basically powers the procedural non-destructive workflow, taking that idea from Houdini and basically making it so the application, which is the editor called Graphite, is powered by something called Graphene, which is the node-based backend. And that itself is kind of its own programming language built around the Rust ecosystem. So Graphene, now a continued overview, is basically a visual programming language and sort of a environment, runtime environment for procedural graphics data processing pipelines. You can basically use the existing out-of-the-box provided standard library, which provides you things like raster primitives and vector primitives and the ability to composite those together and do graphical operations between different things like colors and vector shapes and raster and things that generate raster shapes. And basically you have these custom functions, and these are nodes. They're written in Rust, and they're actually compiled to WASM so that they're very portable, and they are sandboxed so they don't have any performance or security concerns. Our performance is reasonably good in WASM, and that they don't have any security concerns. And it's also a pure functional programming language. So basically it's a very modular way of writing these pure functions, and then you can string them together with the node-based pipeline. And then you end up with this Graphene document that you can then run on the CPU or the GPU or even in a distributed computing environment. And we basically have the runtime environment that we provide, which is the Graphene runtime. And it is a CPU and a GPU-based scheduler and a cache manager that basically runs with the ideal of being as high performance as possible, getting you pixels to your screen with minimal latency and with highest quality possible within the time frame you have available and the compute resources you have available. So that is basically the goal for Graphene, and that is what we are now beginning work on as of today, now that we have released the alpha. So announcing the alpha. After 1 year, it has been exactly 12 months since we presented the very first Rust Gamedev Meetup presentation. That was for the second Rust Gamedev Meetup ever. And so that means it has been 13 months since this started, which is awesome. And we're very grateful to have been able to use this as our venue to present the progress at the end of each monthly sprint. So after 1 year and 1,000 stars exactly, we just reached that a few minutes ago, 33 contributors and nearly 500 commits. And also after several premature times that we said we're about to release the alpha, that was about 6 months ago, but we're actually releasing it today. We now have milestone 1 done. And basically the way that we're doing the alpha release is we've moved on from pre-alpha to alpha. And during the alpha release series, we're going to have a milestone 1, which is now available. And then we're going to move on to a milestone 2, hopefully in about 6 months, maybe a little longer. And that is going to be focusing on the node graph system. Then milestone 3 will focus on raster editing and raster rendering. And basically we'll continue with the milestones until we feel like we're ready to move on to beta. And then we are also launching a new website, which I will show off in a minute. So thank you to everyone who has been here in the past 12 months to keep the momentum up, keep the encouragement up, and give us the 1,000 stars. So please keep those coming. If you have not started the repository yet, please do that. It will actually really help momentum and gain traction, get it on the trending list on GitHub and stuff like that. And we will also be posting announcements around various topical parts of the internet, such as Reddit communities and different online forums, Hacker News, different places like that. So if you have any suggestions for good places to put it, communities that you know of that would appreciate the heads up about the alpha release, please suggest that in our Discord so that we can make sure to send out some announcements to those communities. So yes, let's do a demo real quick now for starting out on the website. So this website will be releasing this weekend. It still needs a little bit of polishing, but we have this. I guess I'm just going to scroll through a little bit of it, and I'll just maybe read a little bit also. So our tagline is that we are redefining state-of-the-art graphics editing. Graphite is an in-development raster and vector 2D graphics editor that is free and open source. It is powered by a node graph compositing engine that supercharges your layer stack, providing a completely non-destructive editing experience. Our goal is to provide professional 2D content creation for everyone. It is now finally available for alpha testing. Some of the core features is the non-destructive editing powered by nodes. It is raster and vector art crisp at any resolution, so you have the concept of resolution agnostic rendering. You can zoom in forever, and anything that you drew is going to be re-rendered at that new resolution that you zoomed into. So basically the concept of pixels is archaic. Of course, if you're importing a photo, then you're stuck with the photo pixels, but you can still upscale those with AI algorithms, for example, and it can do that all automatically for you in the pipeline. And then we finally have a procedural superpower as part of your art pipeline. The whole thing is built for the future, powered by Rust. As I'm sure you all know, Rust is the language of the future, and we all want you to get involved. So please hop onto our Discord, jump on our GitHub repository, and please help out. So you can also sign up for the email list once the website goes live this weekend. And please do follow along on these different channels here. And yes, so that is the website. Now, time for a demo. Let's see. We do have the build is live. Okay, so, and yes, so we can go to editor.graphite.design, although I'm not certain that that one is live yet. That one might still be building. So if you go to dev.graphite.design, actually it's also you can also do dev.graphite.rs. I think we're actually switching the domain to that now. So if you go to dev.graphite.rs, that will always be the latest deploy of the version that we have committed to master. And editor.graphite.rs will be the latest stable version. And basically that means that every few days we we promote the dev version to the stable version, and because we've checked that it doesn't introduce any kind of bugs that we weren't expecting, basically it's just a slightly more stable but slightly out of date version by a few days. So if you go to editor.graphite.rs in your browser, you should be able to play with this in a couple minutes, or dev.graphite.rs right now. So showing off some of the features from the last month of work, which has been quite an endurance run for getting many important features completed. So we have now, if we go ahead and draw something, we do have a properties panel, and this allows us to edit the position of things. So I'm going to set this back to the origin. We can set the dimensions. So this is 552 pixels wide. Let's set it to, let's say, 30 by 30. And we're also going to use this transform cage to adjust the scale. And we can change the scaling of things like this. And we have the spline tool now, which is very fun to play with. So you can draw and click and make very fun noodly shapes, which can be useful for some of the more organic styles of artwork. Always fun. We also have the pen tool, which is very exciting. So now we can actually create any interesting shapes we want. I probably should have prepared some sort of actual artwork to draw during this live demo, but I am not quite the best artist. I am a reasonable but not amazing artist. So making something like this live would be interesting. We also now have the path tool fully working. This allows you to edit these shapes and drag around the handles and fully manipulate and control these. We can also split it so that we have something like this. And that allows you to basically make any artwork that you wanted. Previously, up to this point, we were not really able to make artwork of your complete design. We were stuck with somewhat primitive shapes, but now we actually have all of that implemented. We can also rename layers now, which is really cool. So squiggly red squiggly thing, and it updates here. And you can also then change that to be like that, and it updates here. We have, the crop tool, yes. So previously we were always an infinite canvas. You can just keep zooming out and it's just a giant infinite canvas. So now you can go ahead and say file new, and that's an infinite canvas, or new 1920 by 1080, and that gives you a new artboard. And the cool thing now with the crop tool, and we had that last time, but the cool thing with the crop tool is now you can change the bounds of this artboard like this, or you can actually create new artboards. You can have multiple artboards to work on. And as long as you're in the crop tool, you're able to add more of them, move them around, hit delete to delete them, resize them, and that gives you a nice controlled workspace to work in. So you can, you can use that now. Other things that we worked on in the past month. We have, yes, we can also, that was, now we also, if you hit Control-G to create folders, you can drag layers into the folder directly, and it actually shows the little box around the folder. Smaller feature, but it's the little details that count. We have now different cursors that show up based upon the current context. So this is a rotate cursor. This is a resize cursor. This is a vertical resize. This is a top right resize. We have different tools that have different cursors. So for example, also when you are panning around, you have a different mouse cursor. When you have the zoom tool here, it shows the zoom. And I think that basically accounts for all the features that we did in the past month that got us to the release stage. So this is now live. You should be able to go to editor.graphite.rs and play around with it yourself. Please make some artwork, post it in our Discord channel. We do have an artwork showcase channel for that specifically. And we would love to see what you make, especially now that it's possible with the pen tool to create totally interesting and unique organic shapes. We'd be very interested in seeing what artwork you can create for us. And some of that will be posted on our Twitter account, which you can follow. So back to that. Please visit us That is at graphite.rs. Please join us on Discord. That is discord.graphite.rs. That will bring you to the invite link. And yeah, post some of the artwork you make. Thank you very much.
Awesome.
Oh, actually, sorry, there's one last thing I forgot. This is also very exciting. We have Boolean shape intersection. So I can actually do what I just did there and cut out this shape. And let's say I want to make a hexagon and subtract, or let's say I want to union the hexagon together, and we have this little weird shape thing. And you can actually make some really interesting things like that using the Boolean tools. The Boolean tools are a little bit buggy still, but they are quite a good start. And we can continue improving the algorithm in the future and make them even more useful than they are now. But it's very helpful to have that, so you can make multiple shapes and subtract them and combine them together and stuff like that.
I think True Doctor mentioned freehand. Is that a thing?
The freehand tool. Oh, yes, we do actually. We can also just draw ordinary things. And this just becomes a bunch of points, basically.
Mm.
Oh, and then finally we have, I forgot if we mentioned it last time. I forgot if this was this month or last month, but we also have a text tool.
I don't know if we saw it last time. How does, so I know doing text, isn't text pretty hard?
It is pretty hard.
Like fonts and stuff. And
yes, we luckily have several. We luckily have a genius on our team who's able to pull this off with amazing speed and impressive, just impressive speed. Basically, we are using text shaping provided by the library that has been ported from. It's called Rusty Buzz, which is a port of Harfbuzz, which is kind of the open source de facto text shaping library. Text shaping is the process of taking text characters, reading the fonts, reading the characters from the font, and choosing what X and Y position to put each character at.
Mm-hmm.
So basically, we can then look up each vector shape of each individual font and then place them in the correct location. And then for the actual editing portion, that is actually, we even have spell check and stuff, because that is a HTML element embedded inside of the web page that we're currently using for the ability to actually type things, because now we can use the arrow keys to move around, and we can like hold down the control key to jump between words. In the future, we're gonna have to re-implement like all the ability to jump between words using the arrow keys and stuff like that, because once we move on to a pure Rust stack, that will be a limitation. But we're at least right now able to use some of the stuff provided for the browser for this minimum viable product before we move on to having to implement that ourselves. So we can focus on the important things first.
Can text be used as I forget the exact term, but the Boolean, where like, can you put text over top of a block and then have it do like the Boolean negative or whatever?
Let's see how badly this turns out. Aha!
Oh, that's pretty cool. Oh, and you can keep editing. So I think the thing that I find quite unique about this is that you can grab any of the points that make up any of the fonts and then move them around. So like the X here looks really, really creative in a way that I haven't seen fonts before.
Yeah, because you can basically just take the existing text and use that as a basis for modifying it into your own font if you wanted. And then you could, if you wanted to copy just the E, or let's say you like that X, so you want to take the X, modify it a little bit to be all interesting. Make it like like some wings or something, and then you can just duplicate it, and you can integrate this into your own logo or something.
Yeah, there's a lot that you can do with this. I don't know. I've never thought about doing this type of stuff with text, but just looking at this, I'm like, you could really make stuff look, because you can still tell that's an X, but I don't know. You don't see this in other forms of writing and stuff. Yeah, awesome. And also, so I had a few other thoughts. Where did I write them down? Oh yeah, so I like the term pixels are archaic. I like that way of thinking. We like the
layers. I mean, if you're importing photos from a camera, you're obviously going to be stuck with pixels, although we will have the image upscaling algorithm in the future that allows you to sort of sample that at a higher resolution, perhaps even using AI upscaling. But of course, you're still limited by the real world.
Yes,
cameras have pixels, but if you are doing digital painting with a paintbrush, we don't have to bake your mouse movement into pixels. We bake them into paths that get stored. And then that can get rendered again at any resolution you want when you just simply zoom in.
Someone in chat said vector cameras. That would be a very cool future.
Vector
capturing
cameras?
all of the data. Like
Yes, that would
taking
be
a
very
picture with.
interesting.
Also, I also want to say, so back when you came and first showed off Graphite, you had this prototype, or not really prototype, you had the concept art, and I looked at it and I'm like, well, it's difficult to look at this and understand what Graphite will be because of it. But now you're at the point where like you have that concept art put like baked into this web page, and you can go around and you can interact with it, and you can do a lot of what was promised. And so it's definitely been amazing having like this year of seeing where it's come. So yeah, congratulations on the alpha release. That's super big.
Yes, I'm very excited. The team has been putting in a lot of work to make this happen, and I'm very grateful to everyone that has contributed in the past year, and especially the people in the past month who have really, really put in the time to make this happen, because we had to land a lot of features. But it feels finally like it's something you could use for some amount of graphic design. If you wanted an online, a simple image editor, simple vector editor to use for moderately simple things, you can use it right now, and it hopefully has a reasonably good user experience. Some of the other like professional vector editors can be a little bit more difficult to learn and difficult to use, but this is hopefully something that's useful now to the general public for the purpose of simple vector editing. You can always export this stuff as an SVG. Just go to File, Export, and then you can download this document as an SVG and use it for something that you want, which is really cool.
Sort of on that topic, question. Does Graphite properly support saving and opening your projects with preserving the editor state?
It does for the document state. Like if you change your tool, for example, and then you reopen the editor, that will move back to the default, which is the select tool. So things just like the actual active tool, like you can like resize this, and this sort of state for the editor is not currently saved. But the document state, which actually encompasses a lot of the things that you see in the editor, like when you're in outline mode, that is part of the document state, I believe. So nice. This would all be included as things that are part of the document.
And then as for the file format, what does that look like for saving this stuff?
So currently we are using Serde, and it's basically just creating a JSON blob of a description of the entire file. We need to move on to properly supporting the node system in the future. And that one is basically going to mean that we have a very big redesign of the file format. We're going to have essentially kind of like the file will act kind of like a Git repository, which has its sort of internal database of all the changes over time. And your file is actually going to save not just the current state, but it's also going to save the entire history up to that point. Basically, every time you make a change, it's kind of acting like a Git commit. And all of those commits are actually saved in history. So that way you can go back and reference older parts of history if you want. The file format will basically be kind of like a sort of like a Git database almost. Sort of with a history system, and it'll also, of course, be a description of everything in the form of nodes. This is kind of how it is now. Each layer we have, each of these things are kind of like a node. They're sort of just sitting in a tree right now, but they're not sitting in the node graph. In the future, they're going to feed into each other, and that entire thing is going to be a directed acyclic graph, which will also have some level of hierarchy because you'll have graphs inside of graphs inside of graphs. So all of that will be formed in a way where we store those files, or we store the description for the graph in the file, and then that gets versioned into the history system, and the entire thing can then also embed additional resources. So if you import a photo or you import a font, those will be embedded into the file if you choose to, or you can link it to an external resource. And the file basically stores all of the things I just described into a file format we have to devise. Hopefully it can be a reasonably small format by using binary compression to make best use of space.
Yeah. Well, I mean, if I think of like a Photoshop project, and if I've been doing a lot, then I've definitely seen files that are like 100 megabytes. And so I imagine that the file size of a lot of stuff here would, since it's all being described as paths and it's being described as changes on top of layers, then that must be a lot smaller.
Exactly. Yes. So as long as you're not importing actual giant bitmap files, which of course means that if you import a bitmap file, your file size, and you embed it, your file size will obviously be at least as large as that. But in general, if you're doing digital painting, if you're doing most sorts of vector editing or most sorts of all types of editing where you are describing, the file format, or you're describing your work basically in a parametric form,
Mm-hmm.
In that case, it's actually going to be pretty small, like probably only a few megabytes, even if you were really, really using a lot of drawing. Like, if you were just doing painting all day for, several hours of this, but with the actual paintbrush tool, it's storing all of these paths, and that might be a few megabytes, but it's still going to be way, way smaller than a Photoshop file would be.
One thing I'm curious about here is that we can see, or if you wouldn't mind zooming in a little bit to there, it places a point like a little bit along the line. And so there's some places where it's like an edge that we can see the curvature happening. So would it be better to, so something like this, would it just be better to use like a Bezier curve?
But we will have interpolation. This is definitely a very simplified, the freehand tool here is a very simplified form. It's just recording every mouse position at the moment. But in the future,
and I guess smoothing. You can't do better than that. Yeah, so that's true. That's true.
Yeah, we're always going to be having to receive from the operating system the X and Y position over time as just time series data. And then we're going to be storing that raw data into the node graph, but then we will have different things part of the node pipeline that can take those input points and then map them into Bezier shapes, for example, to smooth them and turn them into a spline. Basically, turning this equivalent into the spline tool equivalent. If we did this, essentially, and it would basically apply that spline algorithm in the same way that we're doing it here.
I see.
And it can also do even more complex things, like in addition to storing the X and Y position, it'll store the pressure if you're using a pen tablet, or the angle, the tilt. And all of those different pieces of information can be fed into the rasterization system that's going to rasterize your brushes. And the pen pressure can change the pressure, it can change the opacity, it can change the radius, it could even change like the color or the hue, or basically anything that you could set your mind to. You can use that as a parameter, create a node setup that can change the way that the brush gets rendered according to those different parameters, and make it so it renders something basically however you want.
Yeah, this is super cool stuff. All right, so we're coming up on time, so I'm going to end it off here. I think there's some more questions that are maybe in like the YouTube chat and as well on Discord, so definitely check that out. But congratulations, this is super cool to see.
Thank you. Yes, and please join us on our Discord, which is you can get to through discord.graphite.rs. And if you're at all interested in the very interesting challenges involved in the node system, we are now officially kicking off work on that full time. So thank you.
Awesome. Thanks, Kevin. See you next time. All right. So hello and welcome to the end of today's meetup. There we go. So right here at the end, a few different announcements that I have. First off, as always, newsletter is out. So the Rust Gamedev newsletter for January, all of the stuff that's been happening over the last month, came out a few days ago. So make sure to check that out at gamedev.rs. Gamedev.rs. I got the dark mode. Easy. Turn that off here. There we go. So lots of really cool stuff going on. Oh, there's that's very cool. So lots of really great projects to check out. Great read-ups or write-ups to read. And then also, what else do we have? So yes, the Bevy Jam is starting on the 25th of February. And so I don't know what today is. Today's like, let's say it's 2 weeks from now. It's probably like the 11th today or something. 2 weeks from now. And so I'm pretty excited for this. I saw some mention of it several months ago. The idea of like what would it like what would be cool to have as a Bevy Jam, and I'm definitely glad that this is happening, and it's going to hopefully bring in a lot of people to work on the just games in the Bevy engine and kind of see what's going on there. Now we also had plans of doing a Rusty Jam near the end of February. So since it was going to clash with the Bevy Jam, we've changed it over so that it will be in March instead. And this one's more general, so it won't just be focused on Bevy. It'll just be focused on game development and Rust in general. All right, so I have this, but I forgot to remove it. I haven't done the meeting in a few months. I want to try. I think my current plan for the meeting is I want to just get on Discord at a set time each week. That's convenient for me. And anybody who shows up, we can talk through some issues and stuff like that. And so some of the current ones that are going on. So we have a issue that's discussing the line length enforcement in the newsletter. And so there's been some discussion about this. And then also project showcases. And so this is an initiative that I want to try and do. And this basically comes down to the fact that there's so many really amazing projects happening in the Rust game development ecosystem. And these are games, these are engines, these are tooling, these are just other crates, like the graphic stack, all of this magic that's going on. And it'd be really cool to have a video that someone can just go and watch and kind of see what's going on. And the point of it isn't necessarily to show that or like just to be like a pure show off of what kind of stuff is cool, but instead showing people that there is movement happening in the Rust ecosystem for game development, and that it is an incredibly viable language for a lot of this. And I mean, if you're here, you probably know, like know for yourself, like what it allows you to do differently. But I think some things that really resonate with me, being like a good Go developer. So we heard from Setzer22 today that doing stuff with GD script really leaves you prone to a lot of bugs as you start investing a lot more in software engineering side of things. And me as a Godot developer, I definitely agree with this. And so being able to sort of see, and also the fact that I've never seen the process before today as a video. I mean, I guess I've seen GIFs, but this was an awesome walkthrough. So seeing more showcases, more games, more cool projects going on, I think would be really cool. So if you go to the working group repo, I'll put a link in the HackMD presentation so you can check that out. I do also want to mention that I will post the link to my slides that I'm using here. I'll post it in the YouTube description. And so you can go and take a look, because what I'll do is I'll add slides for each of the presentations and then links to all of those projects. And then another thing I want to resonate that I heard internally when we were prepping for today with like this new platform here. I mean, StreamYard, not super new or anything, but it's really cool to see everybody's faces and have the opportunity to kind of do show and tell that's a little bit more personal. So it's always been me sitting here with my camera on, but I really like the ability to see other people and I feel a lot more of like the sense of community around this meetup. So that is it for this month. We will be back at the beginning of March. I don't think there's any other big things to announce. And so thanks for coming out today. Oh, so today, the reason we had so many people presenting is because I just reached out to a lot of people that were in the Gamedev newsletter. And I'm like, hey, do you want to talk about something? And a lot of people were like, yes. And this is awesome. And so I'm gonna do it again next time. If you have something you want to show off, if like we saw a lot of engine stuff today, we saw a lot of library stuff today. If you're making a game, if you're doing anything graphics oriented with Rust at all, experimentation, playing around with like there was a few months ago we had some people come in and talk about like some work they've been doing with color crates in Rust, and that was super cool, kind of seeing the theory behind that. So it's really awesome seeing a lot of different stuff. So do reach out to either me on the Rust Gamedev Discord, or you can DM me or reach out to me wherever you can find me. So thanks so much for coming out, and we will see you next month.